Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. We are solving this particular S1 paper, which is of October-November 2024, variant 53, and this is S1. So now this is 737. It's a walkthrough paper. So we are starting at 7:37 and let's time our explanation. And based upon that, I will let you know what is the time that you should allot for each particular question. Now, this normal distribution table over here, this I have put it. Of course, you get a formula booklet that is separately. So now for some of the parts, I'll be looking at this table. And this particular thing right over here, that is the special table for some values of P and some corresponding values of Z. The first 6 values are the most prominent ones. Now let's get started with the first question, which is about, what is it about? Let's read it first. Now it says 30% of the residents of this town own an electric car. So up till here, you probably think that it's either about binomial or about geometric because probability of success is given. 3 residents are chosen at random. As soon as you read that there is a number of trials, so therefore over here, this part is binomial or maybe basic probability, something like this. Now it says find the probability either all 3 own an electric car or none of them owns an electric car. So over here, probability of success, that is 0.3. And probability of failure is 0.7. So all 3 own a car. That is, they have the car, or all 3 do not own a car. That is like this. So this can be considered binomial also, but I'm just doing it using the simple method, that is 0.3 into 0.3 into 0.3. That means if this was a tree diagram, so this is car, 3 probabilities multiplying by itself. The same probability multiplying by itself 3 times. And this is failure multiplying by itself 3 times. It's either this or this. Write down the answer for both, add it up. This answer is exact. So leave the answer in this form. This answer is exact. Therefore, there is no rounding off. Keep that in mind. I focus a lot on accuracy. Please do take care of it. So now over here, the next part, it says a random sample of 125 residents of this town is selected. So now it's about 125. Use a suitable approximation. Find the probability. More than 45 of these residents own an electric car. So probability of success is still 0.3. That is the probability of success. Probability of failure is 0.7. The number of trials has changed. So now this is 125. And then we calculate the following. We calculate NP, that is 37.5. This is the mean. We calculate NPQ. This is the variance. And we calculate something extra, that is NQ, for justification purposes. So keep these 3 things in mind. So justify whether the examiner asks for it or not. So therefore, what is the justification? This is justify. Sometimes they give you an extra mark. Sometimes they don't ask for it. Make a habit of doing it. Since NP is greater than 5, so that is NP greater than 5 and NQ is greater than 5. Therefore, X follows a normal distribution. So now over here, the normal distribution, this is the mean and this is the variance. So this is the mean, this is the variance. Make a habit of writing it. Do not compromise on the quality of your presentation. The way that I have taught you over these videos and on this on-campus classes. So that is more than enough for you to achieve your A or A star. Overall A star will be achieved in A2. The next thing. Now it's asking more than 45. So more than 45, since this is normal approximation to binomial, so you have to do something known as continuity correction. So that continuity correction is over here. This particular value cannot be used. You either choose from one of these. So greater than 45, which is the relevant one? 45 is not inclusive. Therefore, this is the relevant one. This is 45.5. Now look at the working. The P is written over here. There is a bracket over here. The variable X is written over here. Greater sign is there. X converts to Z. When does it convert? When you standardize. You subtract the mean, divide by standard deviation. So remember this thing. Yes, we are doing it many times, but still a reminder is worthwhile. So therefore, Z is equals to, so let me write it over here. So let me write Z on the left-hand side. That is X minus mu over sigma. So this thing over here, this is variance. Square root of variance is what? That is sigma, standard deviation. Now you get this thing. Z is greater than this value. First, greater than this value, this is rule number 2, R2. That is 1 minus probability. Z is lesser than this value. There is no need of drawing a diagram. So this is 1.5614, and we are looking for this value. The table gives us this value. So 1.561. Let me go to this table and just over here, 1.5, that is 1.5. And then 6, that is over here, and then 1 over here. So the 6 is taken, this 1.5 is taken, this 1 is taken, that is over here. So 9406 plus 1, 9407, 1.561. So that is 9407. That is all good, all clear. Subtract, you get this answer. And if this answer is exactly 2, 3 significant figures, that is perfect. You don't have to worry. If it's not, you have to round it off. So the first question is about binomial, and it's also about normal approximation to binomial. So sometimes the order is different. Don't expect that this would be question number 6. It can be question number 1 also. So now this thing is done. Question number 2. This was also a nice question. There are different ways of doing this thing. Let me focus on this. I'll focus on one way, which I find very easy. A red, fair, 6-sided die has faces labeled such and such. So now there are 6 faces. The probability of each face is the same, but since there are 3 ones over here, so therefore the probability is 3 over 6. The probability of 2 is 3 over 6. So it's half and half, but I want to keep it in the exact form. A blue, fair, 6-sided die, it also has faces, 2 ones, 2 twos, 2 threes. So probability of 1 is 1/3, 1/3, 1/3. They all are equal. Now, what are the different options? Options for what? Options for the total. The random variable X is the product. The total over here is not the sum, it's the product. They call it the score. So now there are 2 branches from this one, 1 and 2. There are 3 branches from this one, 1, 2, and 3, 1, 2, and 3. So there are 6 options. So red 1, blue 1. So 1 into 1 is 1. 1 into 2 is 2. 1 into 3 is 3. 2 into 1 is 2. 2 into 2 is 4. 2 into 3 is 6. So there are 6 options over here. Now let me remove this thing, which I wrote initially for my own working. So now, are all 6 scores different? No. 1 is alone, 3 is alone, 4 is alone, 6 is alone, 2 occurs twice. So there are 6 options for 2. There are 6 options for 2. Altogether, it's 12. The other options are 6 each. And this is the denominator, 6 into 6, that is 36. So therefore, there are 6 options, 6 options. So there is 36. Therefore, the denominator for each is 36. Now, someone asked this question today on WhatsApp. That is this thing, that should we leave the answer in the exact form when we are filling this table? That is exactly what I've taught you over the years, over the months, not years. So now over here, when we are making this table, leave answer in exact form. So this answer over here is basically the probability that you have achieved. So leave that thing in the exact form. That's all about it. And then they're asking for expectation of X, that is sigma px. Now look at the working over here. Let me choose a red color thing. So this one, red is already used. So let me choose green. This one is multiplied with 6. This 2 is multiplied with 12. This 3 is multiplied with 6. This 4 is multiplied with 6. This 6 is multiplied with 6. So that is what is happening in all of this. Now show all this working. Then show what you obtain after multiplication. Divide once by 36. That is the usage of this exact form. And you get expectation as 3. And the second usage is you can quickly add the numerators. It should add up to the denominator. That means every single thing is taken into account. So that is how this thing is done. Now, someone asked this question that can we make a sample space diagram? Yes, you can. 1, 1, 1, 2, 2, 2. And then over here, we can write 1, 1, 2, 2, 3, 3. You can write down the 36 possibilities. You can also do that. In this question, I preferred doing it this way. So now over here, that thing was probability distribution. So let me just write it over here. So this is DRV, discrete random variable probability distribution. It's about expectation of X. Variance of X was not asked in this particular question. Now this question number 3, this is about normal, and the second part is a really nice one. So now this is normal distribution. The first question was normal approximation to binomial. That is, of course, also normal, but this is just normal distribution, and 2 things are being asked. Again, let me remove all the marks so I can mark it fresh for you. Over here, let me also remove it, and let's focus. Now, over here, it says in this town, the heights of adult males are normally distributed. That's the mean, and the standard deviation is 4.8. The first part, find the probability that randomly, when we are talking about normal distribution, we are talking about one person at a time. More than one person, that would be binomial. Randomly chosen adult male has a height greater than 170. So that is basic thing. And what basic thing is this? The basic thing over here is this thing that we are using the X value to convert it into Z value to find the P value. So that is the story of 7 rules. So now what we do is that we first write down the distribution. Now exams are just 3 days away. Focus on all this nitty-gritty detail. No matter how much have you tried it out, if you don't write these details, don't expect a nice grade. You have to show everything. You have to show the distribution. X follows a binomial distribution. Sorry, this is normal. Probability X is greater than 170. That is this one. Probability Z is greater than standardized X minus mu over sigma. This is sigma square. This is sigma. Z is greater than a negative value. Apply the concept of symmetry over here. Z greater than negative value is the same thing as Z lesser than a positive value. Unless and until this thing is positive, you cannot proceed further. Once you have done this, now you go to the table. Again, let me make you go to the table 1.25. So first of all, let me just erase this thing. And this is 1.25. So this is 1.2. And 5 is right over here. So this is 1.25. And this answer is 0.8944. So now over here, this is 0.8944. And then you write it to 3 significant figures. For example, if you are using this for the next part, which you will be, for next part, use unrounded value. So that's a general rule that was there from O-level maths. Now the next part, a nice part for 4 marks. Now there are different ways, different people teach this. I have my own way of teaching it, and I use number line. Now it says this thing that 60% of the adult males have a height between 170 and K is greater than 170. That means 60% lies between 170 and K. And this 170 is the same number that we have over here. height greater than 170 is 8944, almost 90%. And the other piece of knowledge that I have from the first part is that greater than 170, 8944, that is this thing. That means lesser than 170 is 1056, approximately 10%. So let me write over here. So therefore, lesser than this thing is how much? 0.1056. Now, if I join these two on a number line, so this is K, between these two is 60%, lesser than this is 10%. So therefore, lesser than K is how much? Lesser than K is 60% plus 0.1056. So let me highlight this thing over here. And let me change the color. This is the working that is done. Very simple working, provided you know how to use a number line. So now, first of all, this thing is there from subtraction. So let me just remove this thing because I've already shown it on the number line. So if I join everything on a number line, basically this is what it's becoming. So there is K over here, and lesser than K is 10.56% plus 80 plus 60%. Plus 60%, and that comes out to be how much? 0.7056 or 70.56%. Got the idea? So now this value is by default inclusive. It's a continuous distribution, normal distribution. Now back solving. Now go to the table and go to this value of probability 7056. So let me take you up. That's over here. And this is the third time we are looking at this table. So now we are looking for probability of 0.7056, 0.7054, and 7088, 7054, and add 3. I think that would do the job. So now over here, let me highlight this. So this is 0.7054 and add 3. So that is 7057. And for which values are we reading it? We are reading for 0.5. We are reading for 4. We are reading for 1. So therefore, this is 0.541. That is the Z value. So now let's go back to this, and it's right over here. So therefore, the Z value is 0.541 from the table. This is back solving. So now let's continue with the working. So what is the working? The working is right over here. And now the working is Z lesser than K is this much. Probability X lesser than K. Sorry, first of all, it's X. Lesser than K is this percentage. Z lesser than K, standardize. This value, this is the probability value. This is the Z value already obtained. You wrote it. The rule is when this is more than 50% and there is a lesser sign, therefore Z value is positive. So make sure you write the correct sign. And then what is the next step? The next step is that you equate K minus 176 over 4.8 should equal to 0.541. And that is how this equation is obtained. Make K the subject. So therefore, K comes out to be 178.6. And it says correct to 1 decimal place. Actually, it's 4 significant figures, but this time they were asking about 1 decimal place. Let me again take you to the top. This particular part, focus on this. What does it say? It says that give non-exact numerical answers correct to 3 SF or 1 DP for angles and degrees. That is pure maths, unless a different level of accuracy is specified in the question. So since they have specified 1 decimal place, that is why you are giving the answer correct to 1 decimal place. So now this is 3 questions are done. Let me note down the time for the first 3 questions. And they were comprehensive questions. So we started at 7:37. And right now, this is 7:56. So basically 19 minutes for first 3 questions. And let me just do a deeper analysis. How much are the questions worth? So that is 2 and 5, that is 7. 7 and 3 is 10. 10 plus 1 is 11. 11 plus 3 is 14. 14 plus 4 is 18. So now we have 18 marks over here, first three question. So it's for 18 marks. 19 minutes for 18 marks. This is, remember, walkthrough timing. So if it's walkthrough timing like this, that means for you people, I think for students, when you're working on your own, basically I've done a lot of working. So I think more or less this should be there, but maximum, let's say 25 minutes, maximum 25 minutes max for the first three questions. Now let's move ahead. Actually, no, not 25 minutes. I think it is more. So let me make it 20 minutes. So I think 20 minutes is more than enough because all the narration that I'm doing, that is like you doing your own work. So why should I give you more time? So now over here, question number 4, this is about cumulative frequency distribution. That is one thing that I can see right away. CF distribution, and then what else is there? Something with this thing, and mean and standard deviation. So it is CF distribution, and it is conversion to frequency distribution or vice versa. And then it is about mean and SD. So that is the kind of working that is done over here for all these three things. Now let's look at question number 4. And now the time is 7:58. So now the time over here is 7:58. Let me write it over here. We are starting. And then it says, on a certain day, the heights of 150 sunflower plants grown by children at a local school are measured. Correct to the nearest centimeter. The heights are summarized in the following table. So now this table over here, 10 to 19, 20 to 29, 30 to 39, and so on. This is class interval. You have to change it into class boundaries. So let me write it over here. So let me use this green color over here. Let me just remove this thing. And this is 9.5 to 19.5. This is 19.5 to 29.5, 29.5 to 39.5, 39.5 to 44.5, 44.5 to 49.5, 49.5 to 54.5, and 54.5 to 59.5. So this is necessary if you were drawing a histogram. Right now, you can just do the conversion, and we are interested in the upper class boundary. So this is 19.5, 29.5, and so on. The 7 upper class boundaries are there. Now, also remember, which most people forget, that is from the very first class boundary. Choose the lower class boundary, write it on the side, and the cumulative frequency lesser than this is 0. So this is a very, very important point that you need to take care of, correct? Because this is where the graph will touch the x-axis. Now, next thing that you need to consider, lesser than 19.5 is 10, lesser than 29.5, that is 18 plus 10. Lesser than 39.5 is these three, that is 60. Lesser than 42, sorry, lesser than 39.5 is this plus this plus this, lesser than 44.5. That is 60 is already there. And basically, this is what we are doing. So let me choose a purple marker. 10 plus 18 is this thing. 28 plus 32 is this thing. 60 plus 42 is this thing. 102 plus 28 is this thing. 130 plus 14 is 144. 144 plus 6 is 150. This 150 should correspond with this one. That's a hard and fast rule. And then you plot the graph. There is cumulative frequency on the vertical axis. Yes, I have labeled till 160, but my data is till 150. So as to avoid confusion, let me just remove this, because that is the last point that you can see over here. And these points I've already labeled, make it a bit more prominent. So there are 7 points over here. That is all this thing. And the 8th point you need it because that is where the graph is touching the x-axis. So that's how the graph is drawn. And how many marks are they giving us for the table and drawing the graph? That is this much. This is the cumulative frequency, and write the whole thing rather than shortcut. So now let me choose a black marker. That is cumulative frequency. That is the number of students, basically, number of children. And we have the upper class boundary, which is the heights in centimeter, correct? So these are the heights in centimeter. So that is the upper class boundary. So now part B, what does it say? In part B, let me just remove it. In part B, it says, use your graph to estimate the value of the 30th percentile. That means 30% of distribution lies below a particular value. And we are looking for that particular value. A particular value will be the centimeter thing. So step one, 30% of 150 is 45. So now go to 45 over here. This is part B. Go right, touch the graph, go down, read off the value. So that value is coming out to be 36. It's approximate. Yes, one thing, one very important thing, and let me put this thing over here. One very important thing that I would like to highlight and focus all your attention over here. Very, very important point. That is, when we are dealing with upper class boundaries such as 9.5 and 19.5 and so on. So first of all, this is over here. I can use a jagged line, a line of compression over here. Doesn't make a difference. So therefore, horizontally, you can do the compression. And we are starting with 9.5. Now focus on this. The 9.5 is on the dark dotted line. We don't do this, that this is 10 and then just go a little bit and then draw 9.5. There is no use. So now it's very easy. Make sure the scale is easy. 9.5 till 19.5, there are 10 units. So this is 9.5, 10.5, 11.5, 12.5, 13.5, 14.5, 15.5, 16.5, 17.5, 18.5, 19.5. So make sure it is easy to read. Got it? So take care of this thing. That's one thing. So mark this thing 9.5 on the dark line. So over here, first of all, you have drawn this thing like this. And then this 9.5 is on the dark line. So this is the dark line, and then mark it accordingly. Second thing that I want you to focus is on this thing. That is the vertical line. The vertical axis can never be compressed. Whether we are talking about a bar chart, whether we are talking about histogram, whether we are talking about CF curve, it can never ever be compressed. So that is a necessity. What about the horizontal axis? So when we are talking about horizontal axis, that's no issue. So horizontal axis, this line of compression, that can be drawn, no issue. So that is this thing. This is the line of compression. So maybe this is your y-axis and we are starting with 40. So no issue. So 40, 50, 60, and so on. So line of compression, jagged line like this, that can be drawn, and that's how we can work it out. So this is something very, very important. Take a screenshot, save it for yourself. The next one, calculate estimates of mean and standard deviation. So over here, remember this golden rule that when we are talking about mean and standard deviation, so we have to use the mid value. So X is half of lower class interval plus upper class interval, or X is also equals to half of lower class boundary plus upper class boundary. So therefore, these are the values of X that we use. That is 14.5, 24.5, and all these things are over here. For X bar, sigma fx over sigma f. So this is X into F, and so on, divided by sigma f, which is 150. Leave the answer in the exact form, and that answer was 38.93 significant figures. So this is 38.93 significant figure. But if I am using it for variance, use unrounded value, unrounded or exact value. So in this case, I'm using this exact value that is right over here. So let me focus on this one. So that is 584 over 15. That is over here. And what else am I focusing on? I'm focusing on 14.5 was there. Let me first focus. This is 14.5, 24.5, 34.5, 42, 47, 52, 57. So now it's the same thing with the square. Same thing with the square, just like that. So now I have taught you to draw a table and work it out. I have taught you this method. Any which way you can work it out. Which table am I referring to? I'm referring to X and then F and then Fx and then Fx square. So make a table for X, F, X square, Fx, Fx square. F into X, that is this thing. And then F into X square, that is Fx square, and add it all up, and then you can get this thing. So that is how this thing is done. So now the final answer over here, the mean is this thing, 38.9, or leave the answer in the exact form. Standard deviation is this thing. That is given correct to 3 significant figures. So now we started this thing as 758. This is 808. Now let's focus on this particular question. So now a factory produces 30%, a factory produces chocolate. So there are 3 kinds of chocolate. Let me just remove all this coloring first. Okay. And yes, there are 3 kinds of chocolate: gold, blue, red, and purple. Let me use the same color over here. So there is this gold, this is blue, and this is red. And this 25% is for red, 30% is for blue. So make sure you don't mix it up, because they space it out in such a way that people do mix it up, and that's unwrapped, and that is the remainder. And this remainder is 45%. So now there are 3 colors. So there is 30% gold. So this is 30% gold and 25% red. And then there is 45% that is unwrapped. So now again, that is for this thing. The blue one is the gold one. The red one is the red one. Now these are the 3 colors. Now it says indigo. That's the name of a person. It's also a color. Indigo chooses 8 chocolates at random. Find the probability she obtains no more than 2 chocolates that are wrapped in gold foil. So now the probability of success is this gold. That is 0.25. And this first part, this is about simple binomial, nothing special. So therefore, let me write over here. Right now, it looks like a binomial distribution question. Maybe it will convert to geometric. Maybe something else. Let's see. So the first 3 marks are pretty easy. Probability X is lesser than or equal to 10. So therefore, this is 8C0, success raised to power of 0. So this 0, this is success raised to power of 0. 8C1, success raised to power of 1. 8C2, success raised to power of 2. And then failure is raised to the power of the remainder. So that failure over here is basically a combination of gold and unwrapped. We don't care about that. We only care about the red one. So that is the answer for this particular part. The next one. Now it says Jake chooses chocolate one at a time from the production line. Find the probability the first time he obtains a chocolate that is wrapped in red foil is before the 7th choice. So now what is over here? First of all, you would write that this is a geometric probability distribution. X follows a geometric probability distribution. Probability of success is 0.25. So P is 0.25 and Q is 0.75. And there is a very special rule that comes in handy. Otherwise, you have to do a lot of working. That is over here. That is probability. X is lesser than or equal to n. It's 1 minus Q raised to power of n. And also another one, probability X greater than n is Q raised to power of n. This is for a range of values. So now over here, when we are working with this thing, so therefore this working is there. So for a second, let me just remove this. So now over here, we have the distribution and make sure that we take it like this. And now it says probability x less than 7. It has to be lesser than or equal to. So less than 7, if you want me to draw a number line, I can draw a number line. So therefore, this is over here. This is 7. X is less than 7 is basically what? X is lesser than or equal to 6. That is 6 all the way till 1. So the easiest way to calculate is to use this concept. And this is 1 minus 0.75 raised to power of 6. And this answer is this. So now the second part for 2 marks was geometric. So the first was binomial. The second part is geometric. Now let's see what is on the next page. So on the next page, let me first add a page over here because now this is the first tough question that came this way. And let me just change the order first thing. So now this is like this. Okay. So now it says this person, Kifa. So who are the people before? First, there was Indigo. Then there was this person, Jake. And now the third person, that is K. Kifa chooses chocolates one at a time at random from the production line. Find the probability. And let me also explain one thing over here. Over here, it is necessary in order for it to be geometric, that number of trials is infinite. And then we choose something out of that. So there is no number of trials given. Keep that in mind. So now moving next to this one, Kifa chooses chocolates one at a time from the production line. Find the probability. Second chocolate is the first one wrapped in gold foil, given that the fifth chocolate chosen is the first unwrapped chocolate. I would consider this question to be the most difficult, the most trickiest question of binomial or geometric or some kind of basic probability. Well, it's not that basic, but look at the marks. That is 5 marks. So now when such a question comes, now there are 2 options. If you have worked so far, so good. So this is all good. So this is 2 mark. This is 3 mark. That's half of 5. That is 5 mark. And then this is how much? This is 5 and 5 is 10. And then 10 and this thing is 4. 10 and 4, that's 14 plus 2, 16. So you have achieved 16 more marks. And how much time have you allotted? Let me just give you a very practical scenario. So now we started at 7:58. And right now this is 8:15. And this is 17 minutes. And that's pretty much the time that you would apply. So now the first 3 questions are done. I have done question 4 complete. I have done question number 5 half. And all this thing is for 16 marks. So 16 marks, 17 minutes, not bad, not bad. So now let's look at the total. So this is 18, this is 16, that is 34. So now 34 marks. And the corresponding time is how much? That is 19 and 17, 20, and this thing 36 minutes. So that is a very, very good approach, the timing. That is all good. Now, if you have comfortably played with 34 marks, and now you are very, very safe. So now the rest of the paper, if you are facing any difficult part question or part question, skip for last. So skip for last. So now let me show you how I would skip this part. So let's say I'm doing this paper. I'm finding this thing difficult. So let me skip this part. So now I'm skipping this part and I'm moving over here. So now that was the solution. Now this is question number 6. And let's say I wasted some time in thinking, no issue. So now this is permutation combination. So this is permutation that I can see. This is combination that I can see. And this is 817. And let's see, is this the last question? Yes, this is the last question. So therefore, there is 1 and 3, 4 and 3. Now, again, some difficult parts are there. So 1 and 3 is easy. So now the first 4 marks, they are the easy ones. Let's first try in this particular question. Find the number of different arrangements of 9 letters in the word happiness. 1 mark. HAPPINESS. Now, this is the second time that this word has appeared. So maybe they are running short of words. So now this is 9 factorial divided by, there is 2 factorial for the P's and 2 factorial for the S. So make a habit of writing it. This is for P, this is for S. Of course, you cannot color it. And that is the answer. That's the answer in the exact form, no rounding off. Now the next thing. Find the number of different arrangements of the 9 letters of the word happiness in which the first and last are not the same as each other. So what is the hint that they are giving you? They are giving you that previously you have solved questions in which the first and last are the same. So let's calculate that probability. So the first and the last are the same. That means first is P, last is P, first is S, last is S, either this or this. So now we have this thing that is 7 factorial, because 7 letters are left, divided by 2 factorial. This 2 factorial is for the color, that is S. And similarly, when we have S at the front, S at the end, so this 2 factorial will be for the 2 P's over here. So this 2 factorial is for the 2 P's. So this is 2S, this is 2P. So now when you do this thing, you add up the possibilities. That is 7 factorial over 2 factorial, 7 factorial over 2 factorial, or means add. So 7 factorial over 2 factorial, that is 7 factorial over 2 factorial. So this is 2 times this, and this comes out to be 5040. And over here, this is not the same as each other, not same as each other. So that is without any restriction. Let me just move this on the sidelines. And this is without any restriction, minus together. So this is, hold for a second, without any restriction. That is answer of part 1. Minus this thing over here is this thing, are same as each other. Will give me this answer that is not same as each other. So you do the subtraction. So now this 3 and 1, 4 marks, that is also easy. So let me again go to the top. And this is like 34 minutes, this thing, and 8:15. And then we started at, let's say, 8:16 or 17, I think. And this is 8:20. So let's say in 4 minutes, you can comfortably achieve 4 more marks, correct? So now let's analyze this thing. How much have you achieved? You have achieved 34 marks. You have achieved 4 more marks. So that is 38 marks were achieved more or less in how much time? In like 40 minutes. That is amazing. That is amazing when you achieve this thing. Now we are dealing with the last 12 marks. And when we are dealing with the last 12 marks, you have a lot of time. You have like around 35 minutes. And now, can you comfortably work with this? Of course you can. So now comfortably think and apply your knowledge. And inshallah, out of these 12 marks, at least you would be able to score maybe 6, maybe 5, something like that. So even if you score 5 or 6 out of 12, that is too good. Of course, there will be some difficult parts which you will face trouble in. That is nothing but natural. So now you have, when you have played very successfully, and if these 38 marks are perfect, which they should be, because not a single part was difficult, that means you are already standing at A. And now you are just working towards A star, nothing more. So I hope this is all good, all clear. Let me know in the comment section what you think about the strategy. So now coming back to this, let me first solve this thing. And this one was, let me solve this thing first, and then don't forget that we have to go back. So now over here, it says, let me do the highlighting with an orange color. Find the number of different arrangements. It's still arrangements of the 9 letters in the word happiness in which the 2 P's are together and there are exactly 2 letters between the 2 S. This is for 4 marks. This is tough. Now, there are many different ways of doing it. I always think to find the easiest way for you guys. So now this is the first one of the ways of doing it. And the thing is that one scenario is that the 2 P's are together, yes, and they're stuck between the 2 S. The 2 P's are together, but they're not stuck between the S. Something else is stuck between these two. That is the thing that you have to think about it a lot. And when this is the scenario, it's very simple. 1, 2, 3, 4, 5, 6. That is 6 factorial. And nothing is happening inside the box. So this order is fixed. This order is fixed. So therefore, it's only 6 factorial, which is 720. That first one is easy. So maybe that's 1 mark for this, and then 3 marks for this one. Now make a box of 2 P's. Make a box of S with 2 things on the inside and 3 things on the outside. So first inside the purple box. So over here in these 2, let me mark it. In these 2, choose and arrange. That means permute 2 out of 5. So therefore, this purple thing is right over here. That is 5P2 over here. This is for the 2 green thing. So the 2 green thing, that is what is happening. The position of these 2 is already fixed. So this S is fixed in its position. This S is fixed in its position. For these 2, we are writing 5P2. Got the idea? And 5 factorial. What is the 5 factorial for? The 5 factorial is for 1, 2, 3, the box 4, and this 5. That is 5 factorial for that. So now that is the easiest way of solving this particular thing. Otherwise, you have to write lines and lines of this working as if you are coding something. So this is the easiest. Yes, the question was definitely difficult. But how can you approach it comfortably when you have all the time and you don't have to worry about what is left? So only difficult questions are left for you to try it out. That is when you can think comfortably. So this thing is there. So we played with that 4 mark. This one was not difficult. This one we left it because we were not in a mood of doing the whole paper at once, the whole question at once. That is why we left it. But this one was easy. So it says the 9 letters in the word happiness are divided at random into a group of 5 and a group of 4. So this group formation, that is NCR. Find the probability that both P's are in one group, both S are in the other group. So now over here, what do? We do this thing. That is, there is a group of 5 and a group of 4. So when there is a group of 5, so let me choose a color. There is a group of 5 and there is a group of 4. So if we talk about the group of 5, let's say the 2 P's are over here. So they are fixed. Select the 3 out of 5. This is selection. And don't forget, these 2 automatically get selected. So 5C3, that is it. So 5C3 into 2C2, this is 1. This is 10. 10 into 1 is 10. Similarly, the 2s are over here. Again, it's the same thing as above. It doesn't make a difference whether the 2p's are here, 2s are here, or 2s are here, 2p's are here. The working is still the same. So therefore, 5c3, and this is 2c2, and that is also 10. So the total is 20. Without any restriction, because they're asking for the probability. Always look at these words. Without any restriction. Select 5, 4 are automatically selected. That is 126. So 20 over 126, that is the answer for this part. So 20 over 126, that comes out to be 5 over 31. So I think this was not that difficult. So the 3 marks were good enough. Going back to do that question, which is the most toughest of all, that is this thing. So now let me make you understand the scenario. First of all, let me again remove this color. And now over here, I am talking about these 5 marks. It says Kifa chooses chocolate one at a time. Find the probability the second chocolate chosen is the first one wrapped in gold foil. So what are the colors that I'm using? I'm using color blue for gold, red is 25%, green is 45%. Green is the unwrapped. The first one wrapped in gold foil, given that the 5th chocolate is the first unwrapped chocolate. Now, this is like way difficult. First of all, realize this, that the word given is there. So it's conditional probability. Probability of A slash B. That means probability of A occurring given B has already occurred. So let me first write this thing over here. Now over here, probability that second chocolate is the first wrapped in gold foil. Second is first wrapped in gold. Given, what is the condition? That the 5th is first unwrapped chocolate. So now 5th is first unwrapped. This is also easy. This is geometric. So this much is geometric. That means the last one should be unwrapped. The first 4 should be anything else. It could be gold. It could be blue. Blue is what? There is gold. There is red. That is unwrapped. I mean, they chose some different names over here. So now this thing is geometric. What about this one? The second is the first unwrapped, first wrapped in gold. So now the working is over here. This is gold, this is red, this is unwrapped. Given the condition, let me write over here, this given is the condition. And this is done using geometric, whether you mention it or not, doesn't make a difference. So probability of success is 0.45, and before that, there are 4 failures. So this is gold plus red. That is appearing 4 times. And the last one is this thing. So I hope this is very clear. And I wrote down the answer over here. And then this one, this is the tricky part. That is taking all our energy. It says second chocolate is the first one wrapped in gold foil. So the second one is the first gold foil. And the 5th is the first unwrapped. So this has to be unwrapped over here. That means this one has to be red. Got the idea? Listen to me once again. The given thing is that the 5th is the first unwrapped. So this has to be unwrapped. Second one has to be gold. Can this be unwrapped? No. Can this be unwrapped or red or gold? No. So that means the first one over here cannot be gold, cannot be unwrapped, because this is the first time this is appearing. This is the first time it's appearing. So therefore, over here, what should I write? I should write red. So this is red, appeared the first time. This is gold, appeared the first time. This is what you call unwrapped, appeared for the first time. These two could be red or gold, doesn't make a difference. This could be red or gold. So the sum of the probability is this thing. 25% plus 30% is this. And now this answer is this much. That is the numerator. So this is the numerator. This is the denominator. Conditional probability, divide. This comes out to be 3 significant figures. The answer is 0.248. Now, if someone even misses this 5-mark question, who cares? No one cares, because you have already worked very, very well. So out of the last 12 marks, there was a 5-mark difficult question. That was 6 last part. And then there was this 6 or maybe 5, I think. So this last 5 marks, that was this gold and red and unwrapped. And then there was this 4-mark that was about that happiness thing, the 2S together and all these things. And then there was this 3-mark that was also about happiness, but that was NCR. So let's analyze how much can you achieve easily. So these 3 were good enough. Out of these 3 marks, even if you achieve 2 out of 5, that is amazing. Out of these 4, even if you achieve 2 out of 4, that is amazing. So basically, you are just putting at risk 3 marks. This is risky. You are putting 2 marks. That is risky. So 5 marks in risky situation, that's not bad, because the other 45 marks will make you achieve your A star. So that is a very detailed analysis that I have done in this particular paper, because the exams are very, very near. So that's all from Mathematics with Shahab Yaqub. Stay tuned for more content. Take care, everyone.